warm welcome from Göttingen, from NFTF Health. I'm happy that we got the second episode already of our little podcast-like seminar on secure processing environments. And it seems like we are absolutely current because if you looked at the issue of Nature from May 12th, there was an update on the UK biobank drama I showed last time. So last time we were arguing that data transfer is not a good idea in most cases because you don't have any control of your data. And so the UK Biobank set up the research analysis portal to have some safe environments. And there was a nice article about some issues. The UK Biobank breach prompts the field of genomics to rethink open science. That would be a mistake. That would be the wrong way. So I think we should be the ambassadors to say, wait a minute, don't stop research, don't stop the research analysis portal, because secure processing environments exactly offer what we need to protect our data in full resolution. And along those lines, I'm really happy to introduce to you Jean-Louis Raisaro. He's an assistant professor in Biomedical Data Science Center at CHUV-UNIL in Lausanne in Switzerland. And he's leading a nice clinical data science group, and he's developing advanced data science and AI solutions for clinical research in healthcare. We will see a glimpse. He promised to have a little demo later to show the system. In his talk, we present Chorus, a next generation secure processing environment, exactly for this use case and secure secondary use of sensitive data and for the development of AI application in health. So without further ado, I'm happy that you're here, Jolie or Jael, and the stage is yours. And for the audience, Alessandra wanted to tell some housekeeping.
Yeah. Well, my name is Alessandra Kunz. I also work together with Uli Sachs in Göttingen. And if you have any questions or comments to make, you can add them to the chat, and I will try to announce them on the right spot.
Excellent. So now Jolie will give his introduction, and I will, that's a reoccurring element of our little podcast, ask about the 5 saves at the fitting situations. The first thing we will see automatically is why SPEs are so important for this project, for the Chorus project. Maybe that's the first question, while Jean-Louis is already spooling up his slides.
All right. I guess you all see my first slide. So thank you, Ulrich, for the introduction and the invitation. Very kind of yours. So I'll tell you a little bit about what we are developing in Lausanne, Switzerland, that might be useful also beyond our local setting. I think I don't have to convince you about the urgency of trying to find solution to govern data at scale. I think as Ulrich rightly mentioned, the UK Biobank drama was all over the news, and I think people realized the amplitude of such a phenomenon. So I think what people are understanding, and also on the political side, is that like the current data sharing models are not scalable anymore. I think there's a lot of fragmentation, a lot of different processes that are in place. Even within a single institution, there are different channels on how data gets shared. So this creates a lot of inconsistency, inefficiency, duplication of work, and a lot of non-compliance processes at the end of the day. And all of this, of course, it's a hindrance, so a roadblock to collaboration and research and scientific progress in general. So within one institution, but also across multiple institutions and across member states. So we also, I think, living in a world where there's increasing regulatory pressure both at the European level, at the country level, but also at the institutional level in terms of privacy, security, auditability. So I think, secure processing environments are really part of the solution. I wouldn't say they are the solution, but I think they play a big role in all of this. And I think you all know by now that the 5SAFE framework is a very interesting abstraction on how to describe this secure processing environment, with this notion of making sure that safe people can access that environment, that it's safe, and like where there's no data exfiltration possible, that data can only be transferred out after proper vetting, that only data that is pseudonymized and for which risk has been properly assessed can be processed in that environment, and that all the governance around approval of projects, so this idea of safe projects, it's also implemented. So I think what's important to understand, it's also that secure processing environment are not new. Chorus is definitely not the first and not the last. So I think in the last few years, we've been seeing like an evolution across different generations. I think the first generation, it's what I think can be defined as like secure enclaves, which are really physically isolated environments. So typical scenario is like where you have to access data, for example, in a data center, you have to go physically in the data center, connect in this very locked in environment to get access to sensitive data. And of course, all the security relies on the physical isolation of the environment. So, and this, of course, it's not really scalable, right? It's not fit for purpose for medical research. So things have started evolving towards like this second generation, which I think it's also the more widespread type of secure processing environment nowadays, which is essentially, like there's a level of virtualization on top of infrastructure, which was originally built for high processing computing workloads. So traditional HPC that we can find like in university, also in hospitals sometimes, like virtual machine infrastructure. And where essentially, this infrastructure has been hardened with some security measures. Most of the time is network isolation, right? So where we try to isolate data from the outside world. But like it comes with a lot of limitations in terms of usability, accessibility, and also extensibility, right? Because you're very soon limited by what the infrastructure can provide you, right? So, and of course, we've seen the emergence of this as a sort of a response to this need. But also, at the end of the day, typical researchers are not really keen on working on this infrastructure because they really feel the lock-in environment where they cannot really exploit the data as they would like. And therefore, they try always to bypass and find other solutions, which at the end of the day, it's really about data transfer. And then I think people are realizing this. So we are working towards more the third generation, where is really secure processing environment, which are purely software-based, where security is managed at the level of the software, not anymore that much at the level of the infrastructure, which gives you a lot of flexibility, scalability. So there are many ongoing initiatives at the European level towards this direction, but nothing that is really operational at the moment, I think.
Yeah, we will come back to this slide later. So I marked it. This was slide, the secure enclave slide. So I like it a lot. So we might come back.
Okay.
Good.
Thank you. So what is Chorus? So Chorus, it's a third generation SPE. So it's a cloud native because it's really built on top of cloud native technologies like Kubernetes and object storage. It's infrastructure agnostic, so we built it in a way that it can be deployed on different infrastructure, on premise, on the cloud, like on more traditional HPC infrastructure. And it's really meant for securing data and foster collaboration with a user-centric approach. I think this is really important. And it has been developed at CHUV, so the University Hospital here in Lausanne, for the last couple of years, on top of several years of expertise in privacy-preserving management of sensitive biomedical data. So very important is Chorus is not in production yet for the full hospital. We are planning now a pilot phase that will start in June. Yeah, that's important to know to manage expectations. So so this is really an institutional project. So the main reason we built this was to essentially have a secure processing environment for our hospital to facilitate the unfolding of the different projects, the governance around the data. So as many academic medical centers, the standard way of sharing data is, we do an extraction, we would pseudonymize, and then we ship the data to the researcher, but then there's no control. We don't know what's happening with this data. So there's a lot of trust which is put in the end user, right? So the institution, the governance of the institution decided to invest quite some money to really start building a platform that could serve roughly between 500, 600 research projects per year on that platform. So we needed something that was scalable, that could welcome several researchers and also foster collaboration with external partners because there are more and more projects that go beyond like the single institution walls. Of course, and then people that are outside that need to access the data in the hospital that, so there's a lot of processes that we wanted to streamline with a single platform. Then we have some very key design principle that we follow, and that's essentially are important when we need to take design decisions. So the first principle is privacy by design. So we really believe in this tiered access to the data, starting from access to metadata, aggregate data, synthetic data, pseudonymized data at the end, right? So for us, like Chorus, have to provide this sort of tiered level, so allowing access to just the data that it's needed for the specific purpose, right? Then we work on this concept of policy-driven sandboxing. So you're going to see in the demo, we have really this notion of workspace, where the security of the workspace is managed through a policy with clear rules about who can access, with what permission, and basically we try to provide auditing of everything that happens within this box. And then, as I mentioned before, user-centric design. So we are ourselves users of these platforms because we do a lot of development of AI and biomedical research. So we really try to build it in a way that we ourselves, we could use it without complaining too much. So we also set up like a user advisory board that is like working with us, that we're consulting regularly, and that is made of different professionals. So we have researchers, we have administrators, IT specialists, lawyers. So we really try to get feedback from the different entities that will need to operate and work around the platform. And then, we wanted this to be generalizable and flexible, being able to be installed in different infrastructure. And that's also where we thought, okay, we want to push this as an open source platform that others can use and leverage if they want. So the way it works from a high level perspective is very simple. So Chorus is really a software platform that sits on top like of a Kubernetes cluster. Then the main object is really this workspace that defines a secure perimeter where data can be processed and can be processed by accessing applications that are made available in an app store. are made available by the one who operates the Chorus platform, but users themselves can also add their own applications after validation. And then it's really meant to manage, relationship between data providers or data controllers and someone who wants to use this data, which can be researchers, but not exclusively, right? And then workspaces can have different properties in terms of security, like at the level of network policy, like being open, closed, or just filtered. And then, like a project can go through different steps where workspaces have different flavors depending on which step you are. So more on the technical level, the infrastructure is really built following different layers and different modules. So we have like a front end. So where essentially the user interact with the various components. So it can be the researcher, but also the administrator. Then we have the backend, which is based on Go and interacts with a Kubernetes operator that it's responsible for launching the different resources, for example, applications or working sessions and so on. Data is stored in a data layer. So we have data for the projects that are stored encrypted on a S3 bucket. We have the possibility of having multiple buckets, one per project or even multiple per project. And also we have like a database to store the state of the platform as well as the logs. And then we have a gatekeeper, which is actually the whole authorization layers that it's context-based and that can, allow based on the roles of the user within a different context to perform, specific actions. We are building and Chorus and try to bring it to compliance to different frameworks that are now well spread. So the SATR framework is a UK framework for TRE that brings a certain number of requirements, also in terms of governance and operations of a SPE or a TRE. Then we have the TEDAS 2, which is more at the European level. It's a joint action that define also requirements in terms of architecture and operations of TRE of SPE. And then ISO 27001, which is really the standard for security processes. So we are working towards certifications, this type of certifications. So these are a roadmap. So the project, as I mentioned, started 2 years ago. So we have already, it has always been open source. So under a license that allows use for non-commercial purposes. And we are about to release like the minimal viable product where we're going to launch some pilot projects in a European project as well, and as well as in our own institution. And then we plan by the end of probably this year a release of an enterprise grade version with also billing system that can essentially allow for scalability and operations on an institutional level. So about the use cases that we have now in the pipeline. So we really want to have Chorus as the research platform of our hospital and university. We're also working at the national level in Switzerland with the Swiss Personalized Health Network and the Biomed IT initiative, which was like the second generation SPE. So we're trying to see if we could somehow join forces to make something at the national level, which is more user-friendly than the current status. And we are also working at the European level, especially in the field of clinical neurosciences with e-brains, where we already have like several institutions that are onboarding on contracts and they're ready to share data on a centralized Chorus instance that will be operated at the eBrains level. So why I believe that Chorus but SPR matters now, I think are really a big part of the solution to enable secure secondary use of data and AI development. I think that solution that we've built, it's scalable beyond our own institution. And I think it really aligns with the principle of the regulations, right? European health data space and so on. So voila, we are also ready for pilots and partnerships. So feel free to reach out if you're interested to know more. Voila, demo time.
Maybe a quick break in between. So because there's some questions already piling up. The first I omitted my own question.
Sure.
The one from Vera was what is needed for users to have their own code or applications validated for use in the SPE? I think that's a very difficult one, and maybe you already could say something. Because that's a typical question we discussed in the last conference, because usually those SPEs are very narrow, so you cannot really use the tools you want to use because they have to be validated, and suddenly you end up in CBioportal only with an R Studio or some small other tools.
So I would say there are two ways. So if the application has to be made available platform-wide, so in the App Store, so that everyone can use it, there's a specific procedure where we run some vulnerability test on the application in an automated way. And then if this pass the test, then we can integrate it in the App Store for everyone to be available. Then there's a way, so there's a recipe on how to build containers and containerize these apps and make them available just at the workspace level, so at the project level. Then, of course, this doesn't prevent a malicious user to build something that will exfiltrate data, but we are going to ensure essentially that the network policy of the workspace doesn't make it so easy, right? So I think then it's a mix of it's a balance towards the user or the principal investigator of the project to take responsibility of what's happening within his workspace, knowing that everything is logged, right? So and
you got educated users. They should have a training, I guess, a mandatory training. And they're named, so you can pull them on the ears in case they're doing some weird things.
Yeah, exactly. So I think the idea is not to block users, right, with something very rigid. So, but to train them and make them aware of the risks and of their responsibility, and also of the fact that there's auditing in the platform which is active. So if there's download or exfiltration of data, this is monitored, and then we can investigate. But at the moment, as I mentioned before, this is not in production. So all I'm saying is the plan. Is the plan. So we are planning to build e-learnings that are mandatory for people to follow before they can access the platform, and then provide sufficient freedom, but also responsibility to the project investigator.
Excellent. We're going to bundle the next questions and we go in the demo because that's what I'm very curious about. So then, of course, we discussed a lot about scalability because if you do it for your own group, that's fine. So you got the teams, but as you scale up, the number of projects increases. You have to check all this code, and at one point, you could say, "Wow, now it's too much." I guess you thought a lot about scalability. So the question would be, how many people do you envision for, project assessment? Because there might be a prioritization, which project goes in first, because it has to be checked when the data has to be brought into the environment. We saw this nicely on the left node, and then people can work on it. And about project debriefing, we thought a lot about this, and this would bind more people, I guess, than operating the actual platform. What's your experience up to now?
Yeah, so the design of the platform is really based on keeping scalability in mind. So we from the get-go we decided to work on Kubernetes, which allows scalability at the, I would say, more horizontal level. So we are in the context of our institution, we are partnering with external Swiss cloud providers that can set up virtual private cloud under the control of the hospital IT with Kubernetes, managed Kubernetes services, right? That we can essentially use and pay as we use, right? So the idea is that Chorus can be elastic, right? So if there are few projects, cluster and resources are limited, and if the number of users increases, the cluster allows to expand to add nodes, right? And then users have to somehow cover the cost of their resources, right? So
that was the other question. So cost, I think, would be twofold. One is the infrastructure, I think, which will scale very nicely because the provisioning and deprovisioning is very nicely done in these S3 environments. But I think the cost would be with the service actually. So some projects actually think about, have some cost for setting up the projects and for debriefing the project that might be more expensive. Or how would the charging be? Maybe it's an unfair question because it's so early.
yeah,
But it
so
could be that
actually,
there's a cost for project setup. Yeah.
yeah, so there might be there's a whole business model that we need to figure out, and that's actually what we're gonna run why we're gonna run in the pilot phase to see how much human resources have to be put to support the different projects. But in our hospital, and I think in many others, there are dedicated teams at the IT which are already working to provide services to researchers operating data warehouses and so on. So I think in our setting, the idea is that this team take over on operating the platform, and actually this will lower the effort with
Yeah.
respect to today, right? Because it will centralize requests, it will streamline processes. So the expectations is that the human effort will be lower than what we have today, where there's a lot of fragmentation and a lot of waiting time also for the researchers.
Yeah, and where you have to reduce projects because you just don't have the staff for the ETL or for the analysis. Yeah, I agree
Yeah,
on that. Yeah.
yeah,
Okay, that's the question round for now. We're gonna touch up later maybe. So, but the demonstration, that's where people came,
yeah.
so they want to see it running. Yeah.
Okay, so uh, I hope you can see big enough.
Maybe there's some space if you. Ah, nice.
What about this? Yeah. All
That's
right.
good.
So before starting the demo, I just wanted to show you we have a public website, which is chorustheory.ch. So you can, if you're interested to know more about what I said, you can just go and check it up. You can access a demo installation of Chorus. It has limited resources, and if you want access, you just need to send me an email, and we'll create you an account, and you can play a little bit around. And then we also have the GitHub page where there's everything which is described with Helm charts to deploy this on Kubernetes. So you can also try it out if you want. So going back to the demo, so I'm just going to use the development version because it's the most up to date. So I wanted to show you like the latest features. So I hope it's not gonna have the usual demo effect. So basically, okay, so we assume people have done the training, right? So they get an account, and then authentication works through Keycloak, so it can be connected to standard identity provider services. Most institutions are compatible with this. Once you log in, you end up in a dashboard that gives you a little bit an overview of your current activities. So you can see how many workspaces are active for you. how many sessions. So sessions are really working sessions that you launch within a workspace. How many applications you're running, how many data requests. So I'll explain you what it is after in a minute. And then also compute, right? So compute, we're gonna have like a pay-as-you-use thing, but also where you can pre-reserve quota, right? So you can pay upfront, and then you have like a certain number of resources that are reserved for you on the cluster. And then, once the resources are finished, you're blocked, and then you have to pay more, right?
Yeah, with UK Biobank, you would see your account there. You would see a decreasing of your credits.
Yeah, exactly. And then you have like a messaging system where we basically get requests for, data egress or data ingress or data transfer across workspaces. Then on the left-hand side, you have a navigation menu that brings you quickly to the different parts of the platform. You also have like a small LLM that helps you with onboarding. It's a little agent that can perform some actions on the platform. Right now, it's not connected to the API because it's the development thing. Otherwise, it's going to cost a lot. But essentially, the point of this assistant is also to help clinicians during the different phases of the project. So, for example, we have a lot of people that start, as students, maybe that want to know what they have to do, and then they can ask the assistant. The assistant say, "Okay, you should start with feasibility assessment. That is what the app that you should use," and da, da, da. So it's really also meant to. We have built a RAG with all the documents and the guidelines we have internally that people can use, and query those things. It's more a nice to have, I would say. Then, once you enter in workspaces, these are really the project spaces. So I created one, for the sake of this demo. Essentially,
who would have approved this project? So in a real scenario, we would apply for using this infrastructure, and then would there be a committee maybe in the future deciding, looking at the bank account and telling go?
Yeah, in the case of our institution, so there's going to be like a form that you have to fill out, saying, okay, this is my the funding that I've associated with the sort of the bank account, something like this. And then the project it's created if the ethics committee has approved the project, right? So essentially, there's a gatekeeper at the cantonal level, so the state level, which is the ethics commission that receive all the requests for the projects, has to evaluate the protocols and give authorizations or not to the protocol. So the user in the form will have to put the approved protocol, put all the information, and then once it's all checked, someone can on the IT side, so some administrator of course can open the workspace, but we can also let the user open the workspace by upgrading his access rights, for example. So if you want to create a workspace, then there's a wizard that walks you through the different steps. So where you have to describe the workspace, the purpose. So because it doesn't need to be tied to a project specifically, a research project. It can also be, I just want to create a workspace for my team and work on public data. It can be, right? Or because I want to access compute, just simply, it's just an easy way to access compute. Or I want, to create, a project that it's not a research project, it's more a quality of care project, where I don't need like approval from ethics committee, for example.
How would you load in the data? So that's an issue here.
Yeah, I'll come to that. Okay. I'll come to that. Yeah, in a second. So then you have security, right? So depending on your rights, you are able to define the network policy of the workspace. So by default, it's closed. But for example, you could allow to connection to some specific IP addresses on the internet, or also completely open. and you can allow or disallow copy paste, from your local host inside the SPE, but not outside, right? So this is not possible. And then, reserve resources. As I told you before, like you can define, I want, for example, 8 CPU, I want 4 GPUs, I want cold storage, hot storage, and blah, 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 right? And then access some services that are platform-wide, that comes with Chorus, like GitLab, access to the Kubernetes API directly, where you can deploy, for example, your applications as pods within the namespace that it's corresponding to your workspace, or access to an external HPC infrastructure for, like Slurm type of jobs. So once you are here, there are different things that you can do in the workspace. You have sessions where you can launch different apps. I'm gonna show you in a minute. You have data, you have members, and you have logs, recent activity, and you have resources. And we're also working on having some environmental footprint about how expensive for the environment is your project, for example. But it really depends on the provider if we can get some metrics. Then data. So data, the idea is to make it as simple as Google Drive, right? Where you can bring data in just by drag and drop. So you could, for example, select a local file. That's typical demo effect. Yeah. You could select a local file and import it. Then because I probably had already that file. Yeah. And then you can create folders and so on. So what you see here is just metadata, right? So you cannot do anything, you cannot open these files. The only thing that you can do is to make requests to download, for example. You click here, then your thing get into a basket, and then you can ask two things: either download the data, then you have to submit a request. Like, for example, I have good reasons. Just trust me. And then you're going to submit a request, and the person who has the authorization will give you access, right? It will grant you access to the thing. Or you can, for example, say, okay, I want to transfer my data to another workspace. So this is also possible. So here I just had one workspace, but imagine you want to have two workspaces, one where you prepare data and one where you have external users. So you can say, okay, now I'm done with the preparation. I just want to transfer this to second workspace. And then, you also, the person who is responsible for the first has to approve, and the person who is responsible for the second has to approve the incoming data, right? So we have this mechanism. Then the members can be added. So here I added 2 accounts because I just wanted to show you how it works on the permission level. But essentially, you can add users that have an account on the platform, define the role. For example, I just want this guy to be a member, and then you can see the permissions that they have on the objects in the workspace. And then you also
can see. Sorry, so you can see the safe people in there. So you see if they already got a certificate or some obligatory training. I think that will come with the EHDS. So there's a lot of discussions. So then you could already have your list of pre-trained people and could add them here. That's beautiful. Yeah.
Exactly. So then you can see the different roles. I mean, these don't mean much, but I will come to that. And then you have auditing. So you can see, for example, all the actions that are performed. So here I just added a workspace member just 1 minute ago, right? I tried to create a data extraction request 2 minutes ago. I failed to upload a file 3 minutes ago, and so on, right? So this is visible for the workspace administrator. It can be the PI, can be someone at the IT. So it's really flexible. And then at any point in time, if you have the rights to do it, you can change the security policy and the settings of the workspace. So for example, you can imagine you say, okay, I start, there's no data. It's completely open. I install the packages I need. I configure my environment. Then when data comes, somebody will close it, data comes, and then I can start working, right? So it's really trying to provide this flexibility where depending on the context and on the phase of the project, we can sort of switch gears as needed, right? Then the sessions. So sessions are remote desktop sessions that you can launch, right? And the idea that we wanted to provide is to have something as close as possible as the experience that you would have on your local laptop, where you can access apps through an app store. So here we have just a few on the development instance where the App Store is still very rudimentary, but imagine like the Apple Store or the Play Store of Google, where you have an app, the description, maybe some tutorials, and then you can decide on launching, different versions of the app. So you could, for example, have a specific version of VS Code that you have configured with specific plugins that it's visible just by you, right, on your workspace, as I was mentioning before. Then here I'm launching the app in another session. So we have this possibility of switching from session to session. So you could have multiple sessions in the same workspace. What's happening is that every application mounts the same data volume, so they can see the data. They are in the same network, so they can communicate with each other. With really the idea of replicating as close as possible, and a working experience, right? So you can see the files that were there before, and so on. And then every time you know what's running, you can add members to share sessions. So people can, work within the same session. So for example, if you want to debug code with someone else or show some plots, you can share the screen with people that are members of your workspace. And you can, always go back here and voila. So
maybe a quick question in between. So we were concerned last time that some people might be overwhelmed in setting up the infrastructure and mounting the volumes. But this could be as well as could be a service like a pre-configured data container.
Yeah.
And you would actually connect it to tools. It would be all prepared as a service. Then you would invite your customers when all the configuration is being done, and then then you could invite your clinician with tools which are
Ready
easier
to use.
to work with. Yeah,
Exactly. So
nice.
that's
That's
exactly the
beautiful.
point. And I have another instance, for example. Maybe I can show you this. So there's a lot of work that clinicians do, in annotating, for example, data. So we also provide a lot of, these data visualization tools for imaging or omics that clinicians can use. It's less for data scientists. So that's also why we wanted to build something with a really nice graphical user interface, also for having, less tech people being able still to collaborate on this project. Then, I'm jumping from one session to the other. So the also nice thing that we have is that you can also integrate some of the hospital internal services. So for example, we have a data set catalog where the data sets of the hospital are the metadata of the data sets are made available. So from within the same place, the same platform course, you can see what are the data sets and potentially download the data set directly into your workspace if you have the rights to do that. So these are all essentially services and apps that are available and that are modules that you can plug and play, right? So the idea is that
I see the pulse
Yeah.
of some people going up because that was very exciting you showed before. Because this could be,
Okay.
it could be as well the Medical Informatics Initiative, the Research Data Portal, which could include cohort data as well. So this would be there's something we already have up and running. This the catalog site, so that you
Yeah,
can search for interesting studies. And the connection would be, somebody launched the environment, and then you click there, and you go through the access mechanism, and then you could download the data
exactly.
which would be applicable for you into the SPE. This would be, wow, a
Yeah.
nice turnkey solution.
Yeah,
It's
that's
exciting. Yeah.
that exactly I mean what the way it works here. So you have data sets, and then the catalog is really specific for the hospital, but you could sort of take it out and just integrate the one you have. So it can also be like an external service that we interface just in the front end. That's also possible. And then we have other things like we have I2B2 like as a Court Explorer on the data warehouse, which is also accessible from within the platform. Yeah, so there are different things. So it's the point is that depending on the deployment and the installation, the institution might have already a lot of different services that they want to interface within the SPE, right? So essentially they could plug their applications either by deploying them on the cluster or by also simply interfacing them as web services. I think what's important in the end for the researchers is this idea of one-stop shop, right? Where he doesn't have to jump from one application to the other, but he finds everything in a single platform. And then for her or for him, it's just no brainer. I know I need to go there. I
Yeah.
will find my application and so on.
That's beautiful. So we're going through because so we got the safe project, safe people, we got the safe settings. I like that a lot. Safe outputs would be still open.
Yeah,
How would that work? Yeah.
the save outputs, it's great that you asked. So it's really about this data request. Before I submitted a data request to download, and then essentially the person who has the right, here I was PI administrator of the workspace, so I by default have the rights, but essentially there should be a human in the loop that has to validate the request. And then if the request is validated, then the file can be downloaded. So that's very simple, right? So any data ingestion, transfer within workspaces or transfer outside, it requires a validation, right? And of course, it really depends on the governance that the institution
Yeah.
or the consortium will implement around Chorus. So in the hospital, we decided to leave the responsibility to the PI to do that, or a delegated of the PI, a data manager, right?
Yeah.
Because of
I
course
agree.
the IT cannot check everything, right?
Mm.
But at the same time, when you're an administrator, you have a dashboard where you can see, everything that happened, all the data requests. You can check what was going out. You can have audit logs across the
Mm.
whole platform, search in the logs. You can see at any point in time all the running apps
Yeah.
and so
Yeah.
on, right?
So,
And
so
you
it,
also,
it maybe it's a quick observation. So I like this a lot. So you tell you have to trust people. You've got contracts, and worst case, you can actually go after the people if something should be fishy. So we should learn from the Swiss. So the Germans are always afraid to be in jail when they allow and see something like that.
uh,
So I see, uh, yeah, it's more like the British policy as well. They tell, well, if your people are trained and we do the best as we can, so we do logging, etc. Uh, I think how internally this could work. The question would be with the data egress. That's what people are most afraid of. The question from Astrid Seidel would be, is it only the data she writes original data. I think it thought the results of the analysis, or could you export plots and all the stuff as well?
it's anything, right? So you could export um, basically
Depends on the
any file
policy, right?
format. It depends on the
Yeah.
policy. So if you
Mm.
allow, the PI to be fully responsible on checking, then it's his job, right? To make sure that what you export is really a
Mm.
result and maybe not individual patient record.
Yeah.
But you could also block it, right? And just delegate this to some IT personnel or somebody at the DPO, but at the cost of, slowing down the whole process, right? So
Yeah.
in the end, it's always a matter of a trade-off between the trust that you put in the end users and the resources that you have to control the whole thing, right?
That's what we see with the research analysis portal in UK Biobank. Getting security means closing it and not letting anybody work on it.
Yeah, then
So
I think
I,
there's a lot of interesting research on try to scan whatever files is requested
mm,
to be
mm,
egressed try to find
yeah,
some vulnerabilities. And I think also something I just wanted to mention is that like the platform comes with a set of roles that are defined by contexts. So at the platform level, workspace sessions, with the possibility of creating new ones or modifying the existing ones. So it's not rigid where you have this set of roles and you have to play with it, but you
mm,
can add your own and make it really specific to the policy and governance that you want to enforce, right?
mm.
So I think this is something that this dynamic access control, I think it's something really we've been pushing a lot.
Okay. So we have 3 minutes left. So what do you want to show us? The candy or the dessert? You
So
say we shouldn't miss that one.
no, I think I made the whole tour. Yeah, what you can do is also you can personalize the theme. This is more for the geeks. So you can have your own logo, your own colors. We have also a light mode for the people who don't like the dark mode. Yeah, you can also bookmark pages, so to have like quick access through the lateral menu. I mean, there's a lot of things that you can do to enhance the user experience, and I think what I want to really pass as a message is that SP has to be software based. Nowadays, it provides so much flexibility, extensibility, and the second generation SP, I think they're lagging behind really in terms of user experience, and I think this is really the key for adoption. I think we can really be creative and try to make an environment where the user doesn't feel
Yeah.
forced to work, but will want to go because it will find data, processes, access to compute, something transparent,
Mm.
and then everything is streamlined.
Yeah, I think we saw nicely now, trying to sum up, we saw very nicely the domain that you have to have this secure environment. Then you have to have a way how to load in data. We saw that it could be pre-configured. I think that's going to be a very nice solution if you already got pre-configured containers, containing one part of a cohort or data release. And then it would actually let people apply for the data use, and then it just pre-configure everything and just allow them for using this part. I think this could be a really good way to use an SPE and to be GDPR conform. One question I have on my notes, so in Germany, they want to see the BSIC5 certification. But I think once you got 27001, you would have to specify the cloud-specific extension, which was a huge discussion in Germany. So, which computing center will actually do it? I guess they all have to do it, one point or the other. And
Yeah, yeah.
good.
And
So we
then I
did a
see
full.
also see questions about archiving. So I think
Okay.
archiving it's like at least at the moment it's really a separate system.
Yeah.
Um, I think we can provide different type of storage, object storage, which is
Mm.
low and cheap, but also like file system storage, which is faster and more expensive. But I think archiving deserve its own solution.
Yeah, I
Um,
agree. That's a separate problem. So what all actually it is a problem. So what of the
yeah,
algorithms and the steps in between do you have to keep according to good scientific practice? So we discussed that as well. I think there's no simple answer on that.
yeah. And I think in the end, the way I see Chorus is really as an SP that is as good as the services that people can put in it, right? So this idea of application, there's a lot of good things that already exist, so you can easily integrate them as long as they are container, they can be put in a container. And then I think a lot of this questions can be solved by software that already exists.
Yeah.
Chorus is really the envelope. And then, there was also a question. Sorry, I think it's important, the open source.
Oh, yeah.
I think the sustainability of the open source is complex. So we have built all of this on grant funding and soft money. Luckily, the institution see a lot of value, so they have stabilized quite some developers that will keep maintaining this, at least on the CHUV level. But we're also exploring possibility of setting up, more enterprise versions with other features that a spin-off could commercialize at some point. So we are thinking
and
a
harden
lot
the
about
software.
this.
Yeah. We have a lot of issues with it, as it gets closer to patients. Maybe you have some, preparing some decision support, then the software should be validated from somewhere. But I think that the model gives it. So you can say, I have a easy, just for checking out app. Maybe I have another one which was from beginning on with quality control, which can use closer to the patient. So I think that's
Exactly. So I think it's still very in the beginning, but there are different options.
Okay, last chance for questions in the chat. I think we did eat it nearly all. So otherwise, I would like to wrap up. I think this was awesome. Thank you very
Thank you.
much, because you showed us the problem we all, at least I have in my head, is that it's a very technical solution. People are suffering when they have to use it, that it's not scalable. And we saw very nice inspiration for our projects.